Hello and welcome to Gaffy's Grinds. Stick your phone on silent now to stop it from distracting you, and make sure you do the questions when I ask you to. Today's video, we're going to learn about something called collision theory. Collision theory has to do with chemical reactions, and in a chemical reaction, we always start out with reactants. So these are the chemicals that we start with at the beginning of the reaction. These are the reactants. And reactants always mix together and they react. This arrow shows a reaction to produce, well, the products. These are the chemicals that we produce in the reaction. So reactants mix together to produce products. Now, if we were to show this with a model, we would say that these here are the reactants. So the reactants react together, shown by that arrow, to produce these chemicals, which are the products. Now, a closer inspection shows us that actually it's just the same atoms that we started with, which have recombined or rearranged themselves into a new structure in the products. There's no new chemicals, there's no new atoms there that weren't there in the beginning. Now, for a reaction to occur, these bonds, these are chemical bonds, these lines, and these bonds are going to have to break. So if we want to separate these atoms so that they can join with each other, we first have to break the bonds in the reactants. And then we need to form new bonds to make the products. New bonds are formed in the products. So that is what happens in a chemical reaction. The bonds in the reactants break and the bonds in the products, new bonds get formed. Now, if we take a look down here we've got our 4 atoms which are separated. Now, as you can hopefully tell, these are just the reactants and we have broken the bonds. So once we break the bonds, how are we going to get them to react? Well, the key thing here is that if I highlight this one here, these are obviously going to be moving around the place like this. Okay, so they could be moving around to there, moving around to there, and they will all be moving around in whatever container you're mixing them in. And eventually they're going to come to the stage where they approach each other and they will crash into each other. And we call this a collision. We say the particles collide. Now, when they collide, sometimes they will, like if they're going too slow, nothing will happen. It will just bounce off each other and they will carry on moving about. So they're all moving about in a container. So now if we draw this one is moving around as well, and this one is moving around as well. So they're all moving around. And like I said, some of them are going to actually crash into each other and collide, and then they're going to bounce off each other and nothing is going to happen. So not every collision is going to result in them forming a new bond. So for them to collide and form a new bond, we say they have to collide in a successful collision. So eventually, 2 of these are going to come close enough, and they're going to collide, and they're going to collide with enough energy to make them react together. So they're going to collide with enough energy to make them collide together. And this is what we call, to make them react together, this is what we call the activation energy. Now, it's the minimum amount of energy that particles need to collide with for a new bond to form. So if 2 particles collide and they have the activation energy, they will make a new bond and we will form the new product, but only in what we call successful collisions. So a successful collision is one where a collision occurs and the particles have enough energy. They have the activation energy. Okay, let's take a look down here. So here we have the situation where we have our chemical reaction. We have our reactants and our products, and our bonds are breaking in our reactants and forming new bonds in the product. And basically, the idea here is that if you want them to react, if a reaction is going to go ahead, then we need, first of all, particles must collide. And the second thing is that the particles must have the activation energy. The activation energy. If both of these things are true, if the particles collide and if they have the activation energy, well, then we get a chemical reaction happening. Okay, so then we have enough energy and they will react together to produce the products. You get new bonds formed and you get a successful collision. All right, it's time to do some practice now. Let's have a look at some questions. All right, so what I want you to do, first of all, is I want you to just do the first three, first of all. In the first three, you just have to complete the sentences. So what I want you to do is write out the full sentence, or just fill in the blanks that are missing or finish it off. But don't just write the end and write the full sentence for me. Okay, so pause the video, do 1 to 3 now. Okay, so for a reaction to take place, the particles must something and something. So here we're going to say they must collide. Okay, I need to make my pen smaller. Sorry about that. So the first thing is they must collide, which means they crash into each other, but collide is the way we say it. They must collide, and they must have the activation energy. Well done. If you said that, if you didn't, you need to add it now. You need to fix it. Hopefully you did. We just talked about it. Right, the next one. During a reaction, the bonds in the reactants must, okay, so these are the reactants. These are the things at the start. Well, the bonds must break. Well done. If you said break. And during a reaction, the bonds in the products, and what must they do? They must form. Okay, so bonds break in the reactants and they form in the products. Good. Let's look at number 4. Which phrase describes the amount of energy required for colliding particles to react? Okay, so pause the video and answer that now. Okay, so you should only be watching if you've answered number 4. That phrase is activation energy. So well done if you said that. Activation energy. And again, you should have a full sentence. I'm just giving you the key word. Activation energy describes the amount of energy required for colliding particles to react. That's a full sentence. Activation energy describes the amount of energy required for full particles to react. Colliding particles to react. Right, number 5. In this one, you have to put the following steps in the correct order for what happens in a chemical reaction. Now, what you should do is you should write them out in the correct order. Don't just write A, B, C, and D, or 1, 2, 3, and 4. Actually write them out, because you're practicing right in the steps of what's happening, and that's going to help you to learn it better. So pause the video and answer number 5 and answer number 6 as well. So number 5 and number 6, let's do that. Okay, so you should have put these in order and then written them out in the correct order. Okay, what should that look like? Well, first of all, we have to figure out number 1. Okay, so this is what you should have written first, this one here. First of all, the substances have to be mixed together. Okay, before they're mixed together, nothing's going to happen, so they have to be mixed together. Okay, the next thing that's going to happen is that the bonds between atoms in the reactants, these are going to break. The first thing, mix them together, bonds in the reactants break. Okay, the next thing is that the particles collide with the activation energy. That's number 3. The next thing is that the bonds form between, oh, sorry, no, actually, you know what? I've missed one, haven't I? So bonds break between the reactants is number 2. Some collisions will be unsuccessful, would be number 3. And particles collide with the activation energy is number 4. You could probably reverse them. If you've got them in the other order, then that's okay. But this is 1, this is 2, and then these 2 are 3 and 4. It doesn't really matter if you wrote them in the other way. And then the last thing is that the bonds form between atoms of the product. So well done if you said that. Good job. Last question then is, what is the activation energy? Okay, so what you should definitely have mentioned here is a minimum. The word minimum should be in your answer. Okay, and it's obviously an energy, so it's going to be a minimum amount of energy. Minimum amount of energy. Now what for? Minimum amount of energy for, and the next phrase you should use is successful collision. You definitely need that. All right, so you're going to make a sentence and it has to include them phrases. So if yours didn't include them phrases, you need to add these in now. So it's the minimum amount of energy required for successful collisions to occur. Okay. All right, let's go back and do another little bit of explanation. Okay. Where are we at here? Here we go. Right, let's take a look at this container. This container has two chemicals mixed together, and the particles they're moving. So I'm going to show that by drawing these movement lines. Okay, so as you can see, some particles are moving very slowly. Some particles are moving quicker, shown by more movement lines. And this is very normal. In a reaction, some of the particles will be moving very quickly, some of them will be moving more slowly. Just depends on the conditions in the container. Okay, now these two particles in the center here, these two are moving towards each other. Now, eventually they might collide. Okay, but that doesn't mean that they're definitely going to react. So if we want them to react, then we need to try and make sure that the collision is successful. So if we want to increase the chance of a successful collision, so to increase the chances of a successful collision, of successful collisions, well, we can do this in two ways. If we want to increase the chances of a successful collision, the first way you can do it is, I suppose, you can add more of the reactant particles. So if we add more particles in here, well, what's that going to do? That's going to increase the chances of collisions. If there's more particles, it's more likely that they're going to crash into another particle. So if I'm a scientist and I'm trying to speed up the rate, or I'm a business owner, I'm trying to speed up the rate, one thing I can do is I can add more of the particles that are supposed to be colliding with each other. So that is one approach. So that is some of the orange ones, and I'm going to add some more of the green ones now. So by increasing the concentration, the amount of reactant particles, that gives me a higher chance of a reaction occurring. So here I have filled up the container with much more particles. There's more chance they're going to happen. So that's the first one. So I call this increasing the frequency, which just means how often. Increasing the frequency of collisions. I do this by adding more reacting particles. So by adding more, filling up the container with more particles, there's more chance, or more, it's going to happen more often that you get collisions. We call this the frequency. So increasing the frequency of collisions means increasing how often they will happen. The other thing is, like I said before, these two particles in the center here, shown by these arrows, these might collide, but there's no guarantee that there's going to be a successful collision because they might be going too slow. So the other way I can do it is try and increase the amount of energy that particles can have. And you can imagine maybe ways that we might add extra movement lines to these particles. But in the next few lessons, that's what we're going to be talking about. What ways can we increase the amount of energy particles have, or increase the frequency of collisions? So the second way we can increase successful collisions is to make the particles have more energy. All right, so in your own mind, I'm hoping that you're already thinking about, how would I make particles have more energy? If I had a substance in a container, how would I give the particles more energy? Well, think about transferring energy. How could I transfer energy to them? Probably the main way we know of doing that is heating. So if we put them on like a hot plate or something, and we transfer heat in, then that's going to make the particles whiz around inside more quickly, and that will give them more energy. So in the next few lessons, we're going to be thinking about how we can do each of these two things. So these are two ways that we can increase the chances of successful collisions, and there's a couple of approaches we can take to that. All right. Now, what I'm going to get you to do is I'm going to get you to take that down. So pause the video and take that down now. Okay, so what we're now going to do is we're going to do a couple more bits of practice. So the first thing I have for you to do is I want you to write this down. I want you to write out the paragraph, but fill in the keywords that are missing, please. So don't just write the keywords. You need to write the paragraph, practice your science writing, and make sure that you fill in the blanks. But do that now, please. All right, so the answers are coming up. So you should only be watching if you've actually done this. Okay, if you're not doing it, you're wasting your time. You're not going to learn as much and you're not going to know it when you need to. Okay. All right, so here are the answers. Collision theory explains how for a successful reaction to take place, particles need to collide with enough energy. The minimum amount of energy needed for a reaction to take place is called the activation energy. To increase the rate of reaction, the frequency of collisions must be increased. Frequency just means how often. So on yours, you can annotate this if you want. Say how often. Frequency means how often. Good idea for when you're looking back on it, that you know what frequency means. Of collisions must be increased, as well as the amount of energy the particles have. All right, let's take a look at last couple of questions. So what I want you to do is pause the video and answer these 2 questions now. 3 questions now, sorry. All right, so let's have a look. 4 tiny particles are moving in a container. So there are tiny particles, and there's only 4 of them. They're moving in a container. If they collide, they might react. After 60 seconds, none have collided as they keep missing each other. How could you increase the chances of some collisions taking place? So the big thing I was getting at here is that you want to increase the number of particles. So add more particles. So if you said that, well done. Increase the number of particles. You might also have said, add energy, give them more energy. Then they're going to move faster. And again, there's more chance that eventually they're going to find each other if they're moving faster. What about the next one? 100 particles. So there's more particles this time. 100 particles are moving and it's a cold container. So think about what that suggests about its energy. They are colliding frequently. So they are hitting each other because there's lots of them. There's 100 particles, but the particles are moving too slow. So no successful collisions are taking place. How could you increase the chances of some, that should say successful collisions taking place? Okay, how could you increase the chances of some successful collisions taking place? All right, hopefully you're thinking about energy here. So you need to add energy so they move faster. You want them to collide with enough energy. And they'll do this if you add energy. If the container is cold, then the particles won't have much energy and they won't collide with the activation energy. So you want to add more energy. Last one, name 2 ways of increasing the chances of successful collisions. This is the same as what we just did. So increase the frequency of collisions, or increase how often you get collisions. And we do this by adding more particles. And we can do this by adding more reactant. So you just put more in at the start. And then what else can we do? We can add or increase the amount of energy. So I'm just going to rub that out. Actually, we're going to increase the energy. So well done. If you mentioned increasing the amount of particles or increasing the amount of energy. Increase the energy. So the particles are moving faster, there's more chance you're going to get successful collisions. All right, guys, that's it for this video, and I'll see you in the next one.